Hello, this is a video tutorial on the program Stellarium. I'm running the Mac version, and I'm going to show you a couple of things about how the sun and the moon move in the sky. I've set up the program for New Haven, and it's 12 o'clock Eastern Standard Time on February the 6th. So there's the sun in the south, not quite on the meridian, but close. And if I look over to the east there, you see the moon not quite first quarter. Now, I'm zoomed out a lot, so the moon's very small. If I zoom in a bit more, I can do that using the mouse wheel or the arrow keys. And if I zoom in here, to zoom in a fair bit in order to see that phase. So what I can do is enlarge the size of the moon, so it's a little bit easier to see. If I go to Sky and Viewing Options, under Sky, I can say Scale Moon. And now I can see the moon 4 times bigger than actual size, so that it's a little bit easier to see the phase. So that phase makes sense because it's about 90 degrees to the east from the sun, so that's first quarter, and it's illuminated on the side towards the sun, of course. I want to turn on a couple of other sky markings, so I'll go back to Sky and Viewing Options, Markings. I want to turn on the local meridian, so you can see where the sun is relative to due south and north. There's the local meridian. You see the sun's a little bit behind the meridian, a little bit east of the meridian. That's just the equation of time correction. I also want to turn on the celestial equator and the ecliptic. All right, so that's the ecliptic. By definition, the sun is always on the ecliptic. And then this blue line is the celestial equator. And you can see the sun's quite a bit south of the celestial equator in February. You can see that its declination is this number right here, and so it's about negative 15 degrees, 30 to 33, I guess, arc minutes. So quite a bit far south because we're still in the winter months, and day after day the sun is going to creep along the ecliptic towards the celestial equator and cross it on the spring equinox in March. I can also turn off the atmosphere. So if I go down here to this toolbar, there's an option for atmosphere. I can turn it on and off, or I can just hit the A key to toggle that. And now I can see the stars. And the stars are a useful marker of the celestial sphere itself. Over the course of a day, if I let time run forward, so here we are, you can see time advancing here. The sun and the stars and the moon and everything moves from east to west as the Earth rotates to the east. So I'll also turn on the constellation lines, the classical constellation lines and constellation labels, so you can see where the celestial sphere is. Now, where is the sun going to be tomorrow? Let's advance by one day. So if I go to the date and time window and go to February 6th, 7th, 8th, 9th, you can see the sun is coming back to about the same place in the local sky. But that's how we keep time, is the hour angle of the sun, the angle between the sun and the meridian. So if we come back to 2:36 every day, the sun's going to be in about the same place, but it's also moving up in the local sky. You can see that it's moving up. That's because its declination is getting less and less. That angle is getting less and less. And it's also creeping around relative to the stars. So we started in Capricorn, and now we've moved to Aquarius. And a month later, we would actually be also then in Pisces. Now, right about here, the sun is crossing the celestial equator. So that is the spring equinox. By definition, that's 0 hours right ascension. You can see we're not quite on the equinox at 2:30 on March 20th, but we're very, very close. It says the sun's right ascension is 23 hours, 59 minutes, and 41 seconds. So it just has to creep around a little bit further to be at 0 and negative 0 degrees 2 arc minutes. So it's just a matter of a couple of hours before the sun truly crosses the ecliptic, crosses the equator, I mean. So that is by definition the spring equinox when that happens at that exact moment. Now, if I were to step forward by a sidereal day instead of a solar day, we would see the stars essentially frozen because the Earth rotates 360 degrees in one sidereal day. So I can do that by hitting Option plus. That steps forward by a sidereal day, a star day. So I'm stepping forward by a sidereal day here, and you see that the date of the month is increasing by 1 day, but the time is going back by 4 minutes every step. And that's because a sidereal day is 4 minutes shorter than a solar day. Now you can see the sun creeping along the ecliptic. Keep going here. There it is, going from right to left across the sky, which is to the east towards the eastern horizon. So the sun moves to the east along the ecliptic about 1 degree per day as it goes through all of the constellations of the zodiac. I want to see the moon come by as well, so I'm going to step forward a few more days until we see the moon. There's the moon right there. So there you see an old crescent moon. There's a new moon right between those 2 points, and as we keep going through, the moon is also moving to the east, close to the ecliptic, but not exactly on the ecliptic. So there it keeps going around to the east, and there's another first quarter in May, and so forth. I'm going to go back to February, so I'm going to set my clock here for February 6th, and I want to see where the moon is. There's the moon, and I'm curious to know if there could be a lunar eclipse. The moon orbits close to the ecliptic, but not exactly on the ecliptic. So no lunar eclipse right now because the phase is wrong. The moon has to be full for a lunar eclipse because it has to be opposite the sun in the sky. So if we go forward a couple of days, it starts to head down in below the horizon at 1 in the afternoon. So let's go to later. The full moon rises opposite the sunset. So we'll go closer to sunset. Here we are at 6:22 in the evening. And let's keep stepping forward. And we get a full moon right about there. That looks like a full moon. And are we going to have a lunar eclipse? No, I can see very easily that the moon is nowhere close to the ecliptic. So it's quite a bit south of the ecliptic. So the Earth's shadow is somewhere around there. The moon's over there. No lunar eclipse this month. Well, what about next month? I'm going to go a little later in the evening, so the moon's a little higher in the sky. Well, I need to step forward by 1 cycle of moon phases, and I could just do that day by day, but I know it's 29.5 days ahead. I'm going to jump ahead to March 16th. Should actually be 30 days. And there we see a full moon again. And it's a little closer to the ecliptic, but still not on the ecliptic. And it's also south of the equator now. We're getting close to the sun being on the spring equinox. Let's go to April. So we'll go to April 15th. Oh ho! Now the moon's very close to the ecliptic. You have to be careful though because I remember I enlarged the moon by a factor of 4. I'm going to zoom in a bit and I'm going to turn off that enlarging. So I'll say sky, don't make the moon too big. Nevertheless, I can see that there's definitely the full moon is very close to the ecliptic. So when is the eclipse? Well, this is April 15th in the evening, 10:24. So we need to find how do we make the moon move closer to the ecliptic so we can see that eclipse happen. So let's see. I'm going to just test by going forward in time a bit. I keep the moon centered though, so I'll click on the moon and hit the space bar. Looks like it's moving away from the ecliptic. So I'm going to go back in time. And it looks like it's going to go below the ground, so I'm going to hide the ground. So I'll hide the ground by hitting the G key or hitting that icon. Another option that's useful is to keep the equator horizontal. So when you don't care about the local horizon, because you're tracking something in the sky, sometimes it's helpful to just keep the equator horizontal instead of the horizon. And there is an option for that here. If I click on equatorial mount mode, then what it will do is always keep the horizon horizontal. So let me go back to the moon. So click on the moon and the space bar to keep it centered. And I'm going to zoom in a bit. There we go. So here we are now 7:25 on April 15th. Let's keep going back in time to see when the moon is eclipsed, if it is. So I'm going to go earlier in the day. Now this would actually be during the daytime, but you see the moon is getting closer to the ecliptic. All right, so here is, aha! So it's not when the moon's right on the ecliptic, but there you can see the Earth's shadow falling on the moon now around, this is 1:30 in the morning Eastern Standard Time, and we head into a total eclipse. It's partial eclipse. There's total eclipse right about there at about 2:07 in the morning, and the eclipse is going to last for about an hour, and then we'll have the moon come out right about there. Now I'm curious where this is in the sky, so I'm going to go back to that. I'm going to go back to horizon mode, and I'm going to bring back the grounds. Just hit the G key, and close this, and I want to zoom out. So there we can see where the moon is going to be when it's eclipsed on the morning of February 15th.